Meaghan a warm welcome to Confluence.
All right. Am I good? Awesome. Thank you so much for having us. I'm going to do a very short intro, and then I'm going to hand it off to my teammates because we're going to do this as a group effort, and I'm the least important of the speakers today. But I want to start by saying Orange Sparkle Ball is an innovation and impact accelerator, so we help people develop new ideas. And within that, I think what's unique about our perspective is we really work across sectors. So we'll work with local, state, and federal government. We'll work with universities, we work with corporations, and we work with small business. And so the techniques we're talking about are really applicable across all kinds of starting new projects. And so that's, I think, what makes them unique and valuable. And with that, I'm going to hand it off to Sophie Becker, who will be leading the talk, and you'll hear from all of us during the next 35 minutes or so. Sophie,
Thanks, Meaghan.
It's all you. Thank you.
Awesome. I'm going to take over the screen. Okay, looks like it's up. Awesome. So today we're going to be talking about design thinking from a very high level. It is a methodology that can be used really in depth, but we're just going to be skimming the surface. So Meaghan just summed up who we are really well. I don't need to repeat all of that, but really at the heart of it, we just move public and private organizations initiatives forward and try and solve problems for them. And I am, as Meaghan said, I'm Sophie Becker. I'm a design strategist on the team. I have a history in industrial design and psychology, but I'm going to hand it over to my other colleagues to introduce themselves as well.
Hey, my name is Lily Spera. I'm a public health innovation analyst. Most of my background work is in community-based settings. So I work a lot on implementation and some of our community partners at Orange Sparkle Ball.
Good morning, everybody. My name is Diego Perez. I'm also an industrial designer, graduate from Georgia Tech. I work as an innovation consultant and design strategist in the OSV team.
Awesome. So let's get into it. What is design thinking? It is not just for designers anymore, and it never really was. Design thinking is just a human-centered approach to problem solving, and this can solve any kind of problem that anyone has. But for this presentation, we're going to be focusing on 3 outcomes. So processes, products, or problems. And what does that mean? So when we're talking about processes, we're going to be using an example of a fictional delivery service. Think of a process as any kind of system or experience. Products, pretty tangible. This is pretty much any good. So this can be your phone, it can be, the furniture you're sitting on, it could be an app. But we're going to be talking about a fictional jam because we like to talk about food and I'll get hungry. And then lastly, we're talking about problems. This is a little more abstract, and we're going to be using the example of a real project we had the opportunity to work on, which my colleague Diego will get into a little more, But in Atlanta, where we're based, we had the opportunity to work with Woodruff Park and try and solve the complex problem of how do we get more people to interact with the park. So we did not invent design thinking. It is used by a lot of people all over the world, and everyone has different steps and how they envision it, but it all kind of follows the same arc. And so at OSB, we see it as 5 steps, starting off with our discovery and research, going into our ideation, prototyping, and refinement of our solution, and then finishing off with storytelling. And even though that slide made it look really linear and easy and perfect, it is anything but. So many times you're going to take 1 step forward and 5 steps back and loop around and, think you're done with things and you're not. It is a messy scribble. And it is also intentionally so. So it is an iterative process, meaning we're going to be purposefully repeating steps. And I think you'll probably get sick of it because this little slide is going to keep showing up and I'm going to say, oh, you're not done. You're going to actually start this step over and keep going until kind of at your own best judgment, you are done and ready to move on. So let's get into the actual steps. We start off with discovery and research, and this is the cornerstone of finding a solution. So you need to have 2 clear outcomes from this step, which is understanding what the problem is, so the big picture, and then also understanding who you're solving it for. As we mentioned, design thinking is human-centric, so we're going to be constantly referencing our target user and our stakeholders. And so we're going to start off by asking ourselves the 5 W's to frame the problem. We want to get kind of a problem statement out of this, which is essentially just a sentence or 2 really succinctly explaining what we're doing. So we ask ourselves, what's the problem? Seems simple enough, but we actually kind of want this like Goldilocks answer, because while it's great to try and solve like really big problems, like how do we tackle climate change? Odds are we can't actually solve that with one simple project, unfortunately. But at the same time, we don't want to go too narrow and only try and solve for something that is maybe affecting us. Then we go into who is our target user, who are our stakeholders. And there's an important distinction between these 2. So a target user is going to be someone who's directly using our solution, but stakeholders are other people who are affected by it. So this could be investors, this could be adjacent communities, this could be partners, really anyone who is affected. And I do want to note at this point also, we don't have a slide for it, but when you're going through your 5 W's, you should be doing additional desktop research on other solutions or the problem. This means, just reading articles, calling people, finding out everything you can. And with that, especially in your who question, conducting interviews of people who you think are your users and finding out what their perspectives are and what they need. Because you can make a lot of assumptions, but if you're an outsider, which you often are trying to solve for a problem, odds are they're not all going to be right. Then we're going to launch into the where. So where can this problem be solved? Often we want to solve things on the biggest scale possible, so global, universal, but sometimes it's best on a community level or a national level, and understanding that scale is going to be really important for the success of your solution. Then when is this problem present? This can be really tangible things, like maybe it's only happening at 3 p.m. every day, or maybe it's happening seasonally. But with that, we also really want to ask ourselves, is this a temporary problem that's just going to pass on its own, or is this a permanent problem that we need to solve for long term? And that's going to affect the longevity of our solution. And then lastly, and what we're going to be constantly also asking throughout this presentation is why? Why is this a problem? Not going to be an easy answer usually. And like I mentioned with conducting interviews and research, you might have some assumption going in of why this is a problem, but it could be totally off. And it's important to have an accurate understanding of that in order to accurately solve for it. So once we have kind of our clear problem statement figured out and a good idea of who we're solving for and hopefully some strong interviews and research, we are going to create personas. And this is just a fictional character of our target user. And it seems kind of silly when you're making it because you're like, this isn't a person and we're naming him and giving him a life story and we're constantly referencing this guy Mark and he's not real. but trust me, it's really valuable and you need to make one. At least one. That's the other thing. With target users, it's not just one audience. So, for example, here we have this guy, Mark. He's 37. He's married with 2 kids. He's an innovation specialist. That's all great. But specifically when we're talking about our problem, so let's use the example of a delivery service. Maybe Mark really wants to have the ability to just, type into an app and have his groceries delivered because he's really busy with 2 kids and a stressful job. That's a really different perspective than, say, someone who's a little older and maybe doesn't have access to a car and physically can't get their groceries. And we can't merge those 2 people into one user. We want to have their unique experiences different in order to solve for those different needs. So we get their general information. We also want to look at how they interact with our problem. So, what is Mark's ideal grocery shopping experience? What does he value in an experience? And what does he hate about the current experience, or what are his needs? So once we get Mark and maybe a few other people, it's time to take them and make a journey map. And a journey map is just a visual exploration of the behaviors and feelings of our target users within the experience we're solving for. So here we have a really great visualization of a San Francisco tourist BART ride, which is just a subway train. And it takes them all the way from when they get on an airplane from whatever other city they're in to them getting to their Airbnb or hotel in San Francisco. And the BART ride is just a step in the process, but we want to look at how they feel when they're getting on the plane and how the BART ride factors into that. And just understanding both their external behaviors and also how they're feeling in order to identify what is and isn't working in the system and how to solve for it. And so those are just 2 tools of many that you can use in this process, but constantly just trying to ask yourself, what are we solving for? And making sure you have a really clear picture of that. And then also making sure you have a really clear picture of who you're solving for. And be ready to reference this information that you've gathered. Don't just file it away and never return to it and say, oh, we're done. You're going to be constantly looking at it and having it define every other step in the process. So I'm going to hand it over to Lidis and Diego to walk us through what this would look like for a few of our examples.
Thank you, Sophie. So like Sophie mentioned with our delivery service, we're going to go ahead and start with that example. So we go through these processes and we find out that our problem statement really is that people who can't leave their homes need a way to have their essentials delivered. So some ways we might have gone through this was creating personas, like Sophie mentioned about maybe an elderly person who doesn't drive anymore. That's a persona that we're creating for. So we do our research and we explore current delivery options and the lives of those who can't leave their homes. For our product, it also looks similar. We're talking about that artisanal jam. Well, maybe our persona is Susie, who's a mom and really wants like an organic, natural jam with no added sugars, and she cannot find it in any of her grocery stores. Well, maybe we'll take Susie through a journey map and find out that she goes to her local farmer's market every weekend, but there's no artisanal jam sellers there. So that's another opportunity that we kind of did through this research process. And Diego's going to go ahead and walk us through our problem example.
Thank you, Liris. As my 2 colleagues have mentioned before, this problem was a community problem, and it's a little bit more in depth that we're going to talk here because we were actually part of the solution of this problem. So the Woodward Park had the Atlanta district of downtown improvement, along with Southwest Airlines, created a grant to increase the engagement of this park in downtown Atlanta. And with them, we were able to work with 2 high schools in downtown, as well as a gap year program and a capstone marketing class of the Georgia State University. The problem with this, the problem that we saw with the park is that not many people were engaging with the park. And with some of the research done, even students from Georgia State University would not go through the park when they had to go from one building to another. Even though it will be a shorter path, they decided, and most of them will go around the park instead of crossing it. So with our help in creating this in design thinking workshops for the high school students, the gap year, and the Georgia State University students, we were able to explore the current experiences of visiting the park and what solutions can be made to bring people and engage the community around the park into visiting and be more community driven for this solution.
Okay. So we have our research. Now it's time to get into the fun stuff. Ideation. Ideation is just brainstorming. It is generating as many ideas as possible that can solve for the problem we just identified. And so when we talk about design thinking, people's first thought is often like everyone's standing around a whiteboard with sticky notes and like making beautiful images and connections and mind maps. That's a really great, useful tool at this point, but also use whatever process works best for you. So maybe that is just using sticky notes or doing drawings or making mind maps or lists or just sitting around and talking with your teammates and putting it on audio recording and listening to it later. Whatever helps you get as many ideas as possible, because right now we're focused on quantity over quality. We want ideas, not the details. And it's important to remember that your first idea is not going to be your best one. In design, sometimes you joke that, your first 5 ideas, like toss them out because odds are someone else thought of them and maybe they're already on the market, which you should have figured out in your research, but also they're probably not going to solve the problem in the way that you think they are. And lastly, think outside of the box. At this point, there is no harm in putting a crazy idea down on paper and up on, your metaphorical or literal wall. So, even though I just said you don't need to make a fancy mind map, it can be really helpful to make a mind map. And a mind map is just a way to organize your thoughts and notes and research. And it doesn't need to look like this beautiful mind map. This was made by one of the designers at OSB, who is a very talented illustrator. But mind maps can be really helpful as you see the literal connections between ideas. You can merge notes with them. And especially if you're collaborating, which you should always be collaborating throughout this process. You don't want to be working in a vacuum. It'll help people connect ideas and see things that they maybe didn't see on their own. And then if you're feeling stuck in your ideation, a really good exercise is blue sky ideation. So this is purposefully creating kind of out of left field ideas. Maybe you're making things like, oh, what if a rocket ship could solve this? What if we brought Jurassic Park back? Like crazy things that make you laugh, put them down and then go back to that board and look at those ideas and ask yourself, what is it about this solution that is exciting, that would work? And extract that kind of core value out of it and try and apply that to a realistic solution. You might just find something that's unique and great. And then it's time to get into critiques, which, not always fun, but think of critiques as just a creative feedback tool that helps you approach your ideas critically. This is really, really crucial in refining your ideas and working towards identifying the best ones you have. And it is, necessary. So it doesn't have to be painful though. There are a few tips and tricks that can make it better. Always be asking yourself why, both as someone who is being critiqued or as someone who is giving feedback. And this is important because it helps you keep things constructive, honest, and respectful. If someone just says, I hate it, you can't really do anything with that. Ask yourself, why you hate it and give that as feedback. And easier said than done. Remember that it's not about you, it's about your solutions. This can be really difficult, especially if you feel like a really strong personal connection, like, oh, this solution is my baby. Be open to feedback because odds are it's going to make it way better. But with that, remember it's a two-way street. So, if you're always getting feedback and you're really resistant to it, but you're giving a ton of feedback, there's a little disconnect there. So it takes being a good feedback giver to receive it. And remember that no feedback isn't good. If no one is telling you like, oh, this isn't working or this could make it better, and they're just saying, oh, it's good from the first start, odds are they're either scared to tell you something or like something's wrong. No one gets it perfect the first time. And then this is an iterative step. So once we get that feedback, it is time to go back to that literal or metaphorical drawing board and continue ideating. And we want to keep doing this until we get, ideally one final solution, or maybe 2 or 3 that, depending on what your end goal is, that we actually need to test, things that aren't just able to live on paper anymore. And I also want to note that, you don't have to have a formal critique in order to get feedback every time. You just need to be getting it in front of people who maybe aren't on your team, ideally maybe some target users or stakeholders, and see what they're saying and, react accordingly. So, ladies, what would ideation look like for some of our examples?
Yeah, definitely. So for our process example, the delivery service, I kind of really see like the opportunity for blue sky ideas to use this here. Just thinking about like, what would the ideal delivery service look like? And I really just kind of pictured that blue sky idea of, dropping the drone, dropping that right in front of you. And it takes you a minute to think about what is it that's so cool about that idea? Well, it's quick, it's efficient, and it's right at your doorstep. So maybe we can't use drones yet, but we start thinking about what are those characteristics that we've loved about those blue sky ideas in our ideation process for that example. In our product, our artisanal jam, there's tons of opportunities for brainstorming in this section with like different types of recipes, right? So you might want to try some weird combinations, mango habanero, and then you go into that feedback loop where you're getting some critique, and you might realize that maybe not a lot of people love that mango habanero, but you take a second and think about, well, what was it that was exciting to me about this? And maybe that it was unique. So you think about different unique combinations that your users would like. So those are just some different ways that you can kind of look like ideation in those two processes. And I'm going to hand it off to Diego to walk us through our problem example.
Thank you, ladies. Yeah, so continue with our Wilfro Park community engagement. We had the ability to take the high school students and the gap year program students to the park and actually have them experience what does it feel to be in the park and what other things can you do at the current situation of the park. And this was extremely helpful because as we progressed in the workshops of design thinking, the students already have an idea of how they need to start processing the information that they're getting from the experience of visiting the park, and that allowed them to move forward with the ideation. And a lot of ideas came out. The mind map that you saw was a mind map that we created specifically for Woodford Park, and it got very, very complicated in a little bit because students were sending a lot of ideas, and they were even creating ideas for problems that we didn't even see at the beginning, not just with the engagement of the community, but who were in the park at the moment that they visit. They had the opportunity to see there was unfortunately a lot of homeless people in the park, with also, that also created some solutions about, okay, how can we help these people by offering jobs and something that we can create in the park. So the main ideas that came out of that solution were a kiosk, which the park already has an existing kiosk, but it's not being utilized as it should be. So there are ideas around the kiosk. There were ideas about live events. How can we engage people with live events, music, art festivals, things like that. A scavenger hunt idea and a coffee cart idea. Obviously, who doesn't love a good cup of coffee, especially when you're around of a campus of the Georgia State University. Students will love that and be around fresh air, if you call it. But moving forward, we decided to go with the scavenger hunt, and we will be talking about the process of that scavenger hunt solution in the next phase.
Awesome. Every one of our meetings for this kind of ended with just an ideation session around different jam recipes, and it was great. We had some good ones. But we have our ideas, now we got to prototype them. And prototyping is just mocking up your solution to see how functional and feasible it actually is in a real world application. And this is really easy to think about, especially when we're talking about products, because it's really tangible. You're thinking about, especially as designers, your cardboard mock-ups, your 3D printed things, your full-scale prototypes. But that it's not just for products. For items like apps or any kind of experience, we can do wireframes and connect how a user would walk through it and what the functionality would be. And even for abstract things like experiences, you can prototype that. So maybe that looks like you and your teammates kind of acting out a scenario, someone pretending to be, in this image, we have a healthcare one. So someone's pretending to be the patient, someone's pretending to be the doctor. You're walking through the experience and saying, oh, this feels right. Oh, I don't really like this part of it, and being able to move on from there. But with that, there are also different levels of fidelity throughout each of these. So just like how you can start off with like a really quick and dirty cardboard prototype, move into a full scale, nearly final version. Same goes for these other examples. You can do it just internally as your team, but ideally you're going to be continuing on and, actually walking your target user through the experience in maybe a somewhat real world setting. Or for things like apps, there are a lot of softwares out there that can mock up a nearly functional version really quickly. And for all the reasons I just outlined, but prototyping matters because it helps us understand, the overall feelings people have of your solution, and also allows you to make really quick changes and pivot and test new ideas in a really inexpensive and low stakes way. You want to be testing things now, not when your product's on the market or your solution is fully implemented. And so when we start off, we want to ask ourselves a few questions about how to go about prototyping. We want to identify what's going to be the fastest and most efficient style of prototyping, but also what's going to give us the richest feedback. So as just mentioned, you can start with these really quick and low fidelity versions and then move on as you iterate onto more realistic final tests. And you also want to have a clear understanding of, how similar is this, maybe last stage of prototyping going to be to the actual implemented solution. And as close as possible is the ideal outcome. Then also, because we're constantly asking ourselves about the user, who will actually be testing your prototype? You want to get it into the hands of your actual target audience, not just your mom and your best friend. We love them, but odds are they're not going to be giving you the real critical feedback you need. And then lastly, you want to ask yourself this kind of as, an overarching question: what do you expect to gain from prototyping? It is really important to go in with a clear understanding of what questions you're going to be asking and what you need to get out of this. It doesn't have to be a super strict scientific experiment. You don't mean taking like super strong data points, but you want to have some consistency to get a general understanding of what is and isn't working for different testers. And as mentioned, it's iterative. So you have your first prototype, put it in someone's hands. What is and isn't working? You go back and adjust. And you're going to keep doing this until we have what we call a minimum viable solution. So this is like a nearly finished outcome. And back to you, ladies, for some examples.
Thanks, Sophie. So for our process, the delivery service, it's kind of funny sometimes to think about what this might look like, but when you have that typical, architect of like a prototype as a product. But a prototype to this can look like a pilot. And what a pilot is essentially it's like a small test that you run to see how this works. So maybe the idea that we decided on was this idea of high school students delivering the food. So we have a partnership with our local high school students. We give them volunteer hours, and that's how it works. And we go through and we run a pilot for the week, and we get a bunch of customers and high school students, and we see how it works. So that's what our prototype would look like for a process. For our product, maybe after trying some of those crazy combinations, mango habanero, they didn't work great, but we picked another one that worked great. And we have about 5 of them, but we need to see if this product, how it's looking. So we create these prototypes and we have a jam tasting party. Again, not with our mom and our siblings and our best friends, but maybe with our local neighbors or at the local farmers market. We hand out free samples and we get some feedback from that. And we see how our prototype holds up in the market that we're trying to deliver it in. And off to you, Diego.
Thank you, Lyris. As I was mentioning before, the solution that was chosen to be prototype and move forward was the scavenging hunt planned and run through the park by the students. We saw that this idea had the most potential because it will allow people to be running through the park or achieving any of the entrances of the park instead of just gathering in one specific point. By taking the students once again to the park, we were able to start prototyping the routes of this scavenging hunt and to take advantage of the current things that are in the park. So for example, we look at the our Police Hand Monument that was created for the service of the Police Atlanta. We went to the waterfall, which is the International Peace Waterfall. We also went to the gazebo, which was made for the Summer Olympic Games in '96, if I'm not wrong. We have the ATL letters made from artists, local artists, And we have other studies on monuments that were placed around the park. So we were able to identify those points of interest for usually the tourist kind of people that will go, and see how can those points can also be helpful to create these routes of the scavenging hunt and the run through the park. And there was a series of iterations of, okay, we have the routes, now what will be the activities or the puzzles that people will have to solve to start getting the clues to get this scavenging hunt at the end. And that was, like Sophie has said, a very iterative process, because we had to take into account all the type of people that will go and visit the park and what are those mindsets in actually engaging to this scavenging hunt plan.
Awesome. Now move on to refinement. And the line between prototyping and refinement does get a little blurry, so stick with me. But refinement is just, kind of the final improvements and clarifications of something with really small changes towards the ultimate goal. And just like prototyping, it's important to remember that sometimes taking a step backwards at this point before you fully launch something, while kind of a pain in the butt, is going to be much, much more important now than when you're fully launched. And remember that, these iterations bring powerful results. And it's kind of a never-ending iterative step. So this is where it does get a little complicated, because within refinement is where we're going to be launching our final outcome. And that doesn't mean that the step is necessarily done, though. Think about how your iPhone has a new version like every year, and apps are constantly updating even after they've launched. So kind of a never-ending spiral. But it's important to ask ourselves when it's time to launch and when we're done. So 2 kind of general rules of thumb is when we are receiving consistent positive feedback from people in those constant feedback sessions we're having, because we're always asking for other people's advice. And then also when there is an independent demand for our solution that is not just our mom's. So those aren't the only 2 reasons. A lot of this is trusting your gut and, being really in touch with your users and the market, or whatever environment you will be implementing your solution in. So, ladies, what does refinement look like?
Yeah, so for our delivery service, maybe in the process of running our pilot, we found out that the high school students weren't as reliable as our users would have hoped. So we decided to refine, and we decided to have a partnership instead with college students. And through this kind of iterative process, the college students are working great for a short time, but then we noticed that maybe we're using a paper system and they start to fall off, orders fall off. So we go ahead and pivot, and we add on an online scheduling service that allows for more consistency. So through that process, it wasn't just one step that we did to make it better. We continuously refined until we had a good minimum viable product that we felt was ready to move on. So that's what that might look like in a delivery service example. For our product example, we want to go ahead and choose the best flavors that we had. So we did some different refinements. Maybe we got feedback that this flavor tastes really great, but it's a little too sweet for me. So we go ahead and lower the sugar content, or, you know what, this looks really, really good, but it just didn't catch my eye. Like the packaging was kind of boring. So we might want to go ahead and revamp our branding style until we have, I guess, a product that we really feel confident about. And it kind of just goes into talking building on what Sophie said about trusting our gut too. And off to you, Diego.
Yeah, thank you, Laris. It feels like we're in the news, right? Like, thank you, Laris, back to studio. Kind of like that. But yeah, continuing with the Woodford Park, this was a very pivotal place to be in this process, because as the students of the high schools and the gap year program came to the solution, we now had to shift teams, and we went with the capstone marketing class at GSU. And with their help, we were able to find that the scavenging hunt idea was the ideal, but not the best solution just yet. Because when you typically run a scavenging hunt, there's always a beginning and an end, and then you have to follow that pattern in order to find all the clues to get to the end goal. And people are not necessarily engaging the park from the same specific entrance. People will come in all directions at any time. So with the help of the marketing class, we switch the idea from be a scavenging hunt to be a art exchange program for local amateur and appreciators of art. And the idea was to introduce yet points of interest that will be identified with mailboxes. These mailboxes were just regular mailboxes that we get from Amazon. But the good thing about it is like we were able to find local artists that paint these mailboxes and characterize them in their own unique ways to bring that attention to the mailbox and to the points. And we were able to create a program that was crafted by the community for the community. And this refinement phase was very crucial because it gave us the opportunity to say like, okay, if you are an appreciator of art or an artist, you can make something, place it on that mailbox, and then somebody else will come and get that piece of art that you created and maybe leave something behind as well. So there's a community engagement and that idea of putting something and getting something. It's like giving to the community and receiving from the community. That's something that we wanted to have very involved and very present into this project. So this refining phase was extremely helpful for all areas that give us a better idea on how we want to engage people to this park.
Awesome. And we are at the last step, storytelling. And as we mentioned at the very beginning, even though it looks like a very linear process, storytelling isn't necessarily the very last step. It's kind of taking bits and pieces from all these previous ones, and you should be thinking about it from the get-go. So what is storytelling and why? Storytelling is just communications, and it is used to help us help other people understand and respond to our solution. And it's important to remember that it is not one size fits all. When we are talking to people like our investors versus potential partners versus consumers, they are all going to be responding to different narratives. However, we need to have continuity between those narratives and have that all fit into one overarching story we are telling about ourselves, our brand, our product. And remember that under that same umbrella, our branding, both our visual communications and just our voice as a company fall under that. Our marketing, our advertising, really all of our communications need to fit this narrative. And so, as mentioned, we should look back at some of the previous items that we've covered to help us start this process. So what was some positive feedback that we were receiving during testing? Maybe we can use that as, key seller points. Or revisit that problem statement. If we did our due diligence with our research, odds are it still kind of holds up. And maybe we can just, workshop that and we have our mission statement or our value statement. And then, maybe we look at where this idea came from. People love a good origin story, especially if it has like a strong emotional tie to it and they can see themselves and relate to it. And then, maybe we're a few years down the road since launch and we can look at how our solution has evolved and kind of create a timeline with that. Or look at if there were any obstacles we had to overcome and use that story of adversity to define us. But whatever route you take, and you don't have to just take one, like you said, there can be multiple narratives under this theme. Whatever you do choose to do, remember that you need to root it in originality and authenticity. People, one, can tell if you're totally making it up and it's not true, but also it's really hard to come back from it if the story brand is telling. It becomes known that it is not actually how they operate or how they actually do business, and tough to come back from. So a good example of this is Planet Fitness. They have really, really strong storytelling, and this is obvious in everything from their visual identity to the way they actually lay out their gyms to the way their ads are, and just kind of this idea of this isn't some pretentious gym for people with like Olympian bodies. It is for the everyday kind of person. They got the no lunk alarm, I think it is. But this has really, I don't know about everyone else, but when I drive past a Planet Fitness, like I think about all these things, and that is the narrative I have in my head. It's important to note that you have control over how, the narrative of your company and the story of your company and product starts, but it will take on its own life, and you want to have some say in that. And ladies, walk us through how storytelling would work.
Gotcha, Sophie. So for our process, here's a really great opportunity to kind of build on the story, right? So instead of talking about this as just a delivery service, we talk about how it really benefits the whole community, and that partnership between our users and the college students, and showing that it's adding value to both people involved and really just solving a problem in the community. So a great opportunity to use an origin story. For our product, our jam, for sure we want to focus on that branding, and make it eye-catching and tell the story about how it's natural ingredients and how we saw the need, that there was no good product and all that stuff. But also there's a really great opportunity here to kind of use non-traditional storytelling and storytellers. So for instance, like once we have our product and we want to go ahead and expand and build. So maybe we work with our local diner or our local bakery, and we ask them to tell our story for us. So when they're going to serve their jam at the breakfast with the toast and everything, and the customers are saying, wow, this jam is great, they become your storytellers and are really pushing your product forward for you by saying, yeah, our local person comes in and she brings them in and it's a great jam, she's a great person, and tells your story for you. So there's a lot of opportunities to think about non-traditional storytelling than your typical communication channels, just really thinking outside the box.
Yeah, and then to continue with Woodrow Park, we decided that it was time, at the time that we just come up with the final solution, we decided it was time to transfer the ownership of the project and the solution to the community. And like Lyris was saying, now the community is going to be our storyteller. Something very important that you need to know is that your story begins as soon as your idea comes to mind. And it doesn't end when your product, service, or process or problem is solved, because I think that's the second chapter of your storytelling. Now, whoever you're serving, whoever you're helping with a process, whoever you're giving a product to, now those people are going to be your advocates for your story. And your story might change, but it's very important that you need to document everything on your process. So when your storytellers and the people who are advocating for your product, service, or process can relate to that core message that you implied in the beginning. So for the Woodward Park, when we have the solution in place, we make a live event where we launch the event at the park, and we created social media tags, an Instagram page as well, where we were giving people the opportunity to go take pictures, share their experience of actually going and finding all these amazing handcrafted items. There was poetry, there was a small crafted little paints, things but just the experience of like going into this park, open one of the mailboxes, and then find these little surprises, and being able also to leave something for the community. And that engagement was very, very well received. This project started in 2018, and it was going to be implemented at the beginning of 2019, and it was only supposed to last a year. And we're in 2021, and the mailboxes are still up and running, which is a great successful story for us that will help us with this storytelling part, that a solution that came from high school students is now implemented in a city, in a park in a city that is involving a lot of people in the city, not just the students, but the local businesses. We have, that around a campus, or a college campus, there's a lot of businesses. There's a lot of people that come in to visit the city, and this is one of the points that we really stressed about, is like, how can we engage people in so many different levels that it's just going to be a great experience overall. And I think part of the storytelling is just how a simple idea can engage so many people and actually create an impact of ownership of the park, ownership of the community, and engagement of the community, and how can one another can give a little bit of ourselves to the rest of the community. So it was a very successful story for us, I will say, and for Atlanta community as well. And just to throw it there, if you go on Google and type ArcSwipe Atlanta, it will take you to the Woodruff Park page, and you can see all the ins and outs about the project.
Awesome. And that is it. But like we said, it's not like, oh, I've told my story, I'm done. You're going to be constantly going back, refining, tweaking your story, adjusting your solution. But at a glance, we start off with our discovery and research. We're defining that who we're solving for and what the problem is. Then we're going into ideation, getting as many ideas as possible down, selecting our best few after we get feedback, prototyping them, testing them, adjusting accordingly, and then going into refinement, launching it, and then finishing off with storytelling and communicating what everything is about. So that is it. Thank you all so much for your time. If you have any questions or anything that we can't get to, feel free to shoot us an email at hello@orangesparkleball.com. But I will hand the floor back to some questions.
Maybe for us, the questions will come into the Q&A chat window, since we are virtually. Or I don't know if we will be able to hear the audience over there.
Okay. Does anyone have any questions? Any questions at all? No? Okay. All right. Don't look like we have any questions. Again, Meaghan, thank you guys so much. An amazing job. You've added tremendous value to us today. So you and your team, we're so grateful for you. And since you're right down the road, we look forward to, you're welcome to come by and visit us here in good old Rome, Georgia, okay? So thank you guys again. Let's give them another hand, guys. Thank you.
Thank you very much. We'll take you up on that.
And we have a special gift we want to present to you. And so I'm going to virtually just hand it off to you, okay? Like that, or even the guys with the cameras up there, okay? Very good. All right, so we'll make sure you get your gift as well, okay? Very good. All right, you're more than welcome. Okay. All right, and again, I took a lot of notes, and I hope you guys are really getting a lot out of this as well, of how you can take some of the things, the different concepts and principles that we're learning, and make real unique application out of it, okay? All right, here we go. Next in line, I want to welcome to the stage a person who I have not met personally, but was a huge influencer for a lot of us this past year. I know I was reading his articles on a regular basis in the paper during COVID-19 as he helped to navigate that whole process. Would you help me welcome to the stage Dr. Voxio?
Thank you. Thank you very much. I'm privileged to introduce to you Dr. Trudy Rey. Dr. Rey is a registered patent agent with 8 years of experience preparing and prosecuting U.S. and international pharmaceuticals, biotechnology, and medical device patents. She has experience drafting and prosecuting patents in the area of molecular biology, virology, immunology, biochemistry, genetics, drug delivery, stem cell biology, and nanotechnology. Prior to joining Mintz, which is a law firm, Dr. Rey was a scientific advisor and patent agent at 2 Georgia-based boutique intellectual property law firms. In those roles, she drafted and prosecuted U.S. patents, provided guidance on non-U.S. patent applications, and served as a scientific advisor on matters related to biotechnology and pharmaceuticals. Earlier, she worked on respiratory syncytial virus vaccine development in mice as a postdoctoral fellow at the Centers for Disease Control and Prevention in Atlanta. During her time at the CDC, Dr. Rey was also a lecturer at Georgia State University, where she designed an undergraduate biology course and supervised teaching assistants at the university's biology lab. While earning her doctorate in molecular genetics and biochemistry, Dr. Rey researched how cyst-acting elements in the West Nile virus jerome affect viral replication and transcription. In addition to her practice, Dr. Rey contributes articles about virology to a university blog and serves as a guest lecturer for university biology courses. She's presented her research findings at regional and international conferences, including the American Society for Virology's annual meeting, the Southeastern Regional Virology Conference, and the Respiratory Syncytial Virus Symposium. In addition to all these accomplishments, Dr. Rey is fluent in German and Romanian. That's an accomplishment in and of itself. Please welcome Dr. Trudy Rey.
Thank you so much. It's an honor to be here. Just like, I'm sorry, what is your name again? Thank you so much. Just like you mentioned, I am a virologist by training. I did many years of basic research at the bench, but I no longer do that. I work as a patent agent now, and I help scientists patent their inventions. So I spend all day, every day, reading, thinking, and writing about topics in molecular biology. However, I will always feel passionate about viruses. So I've been keeping up with virology by still reading the scientific literature in virology, and I also listen to many different podcasts. This is a great one right here, This Week in Virology. They started it in about 2008, and they have many, many episodes. Get this working. It doesn't work. There it is. Many, many episodes. And to tell you the truth, this is a treasure trove of information. If you want to learn more about virology, I highly recommend this podcast. I also write for a virology blog called Virology Blog at Columbia University on a regular basis. I've been doing that for about 3 years now. And I do it about once a month, more often if time permits. And I also tweet quite regularly, as you can imagine, about virology and immunology. And that is my Georgia license plate right there. I am one of 5 virologists across the U.S. who have that license plate in different states. And then finally, I recently started my own YouTube channel where, as you can imagine, I have a show called Catch This, which, as you can imagine, it's about viruses, viral disease, and immunology. And we have been living in this pandemic for a year now, a pandemic caused by a virus, and I've been very, very active with communicating science about this virus. So today I'm not going to talk about patent law, I'm going to talk about this particular virus. I'm really happy that I think everybody knows what a virologist is today. Okay. Oh, it's not working. Okay. So I want to talk a little bit about the virus itself and how it interacts with the immune system. But then I want to spend most of my time talking about the vaccines. I think the vaccines are really, really important. And I'm trying really hard to fight the vaccine hesitancy and all the mis and disinformation that is out there in the general media and in the social media as well. So the name of the virus is SARS-CoV-2. It's not COVID-19. It's SARS-CoV-2, and that stands for Severe Acute Respiratory Syndrome Coronavirus 2. And it's 2 because it's the second one. There was one that emerged in 2002, and it infected about 8,000 people worldwide, and then it just kind of fizzled out in 2003. One of the reasons why it fizzled out is because it caused a lot more severe disease than this one. And when that happens with a viral disease, most infected people end up in the hospital. And that makes it a lot easier to contain. In contrast, SARS-CoV-2 causes a lot of asymptomatic infections. And that is one of the reasons why we are where we are today. So that's the name of the virus. And this virus causes the disease COVID-19, which stands for Coronavirus Disease 2019 because it emerged in 2019. So I want to talk about the immune system, and there's been a lot of talk about antibodies. When we talk about antibodies, we're referring to adaptive immunity. Adaptive immunity, or it's also referred to as acquired immunity, initiates during a first exposure to a pathogen and protects from reinfection against disease upon a second exposure to that same pathogen. This is in contrast to innate immunity, which is a more broad response and to any pathogen that has never been seen before. But very briefly, adaptive immunity is roughly divided into two halves. One half being referred to as humoral immunity because it occurs in the bodily fluids or the humors, and the other half is cell-mediated immunity because it involves the collective action of cells. So briefly, T helper cells are at the center of it all. When a virus or any pathogen enters your body, T helper cells sense the presence of antigens on the surface of that pathogen, and in response to that, they produce a variety of signaling molecules called cytokines. Those cytokines ultimately induce B cells to make antibodies, and they induce cytotoxic T cells to directly kill infected cells. So, of course, this is also what happens in the context of SARS-CoV-2 infection. Throughout the current pandemic, the public focus with regard to immunity has been on antibodies. This is partly because T cells are more difficult to measure and than antibodies, but a well-balanced immune response requires both B cells, antibodies, and T cells. As far as the vaccines are concerned, there have been reports in the media that vaccination induces antibodies that last anywhere from 6 months to a year. However, these studies that show that don't take into account memory B cells, okay? So even when your antibody levels drop to an almost undetectable level, we still have these memory B cells. And when they encounter the antigen again, they are capable of expanding very rapidly, make lots and lots of copies of themselves, and each one of those copies will be able to produce lots and lots of antibodies. And this happens very quickly, in a matter of a day or two. In addition to that, we also have T cells and memory T cells. So now I want to talk about the SARS-CoV-2 vaccines, or at least 4 of them. 2 mRNA vaccines produced by Pfizer in collaboration with BioNTech, and 1 by Moderna. And then there are the virus vectored vaccines, one made by Janssen of Johnson & Johnson, and 1 by AstraZeneca. There are many questions about these vaccines. How exactly do they work? Do they really work? Are they safe? What do we know about long-term side effects? And this is a really important question. How did we get them so quickly? That leads to the next point. Were they rushed? And again, are they really safe? There are really good answers to these questions, but to tell you the honest truth, let me tell you how I felt a year ago. A year ago, when we were promised a vaccine this soon, I was very pessimistic. I kept saying, no way that's going to happen. And that's because I have some experience in vaccine research, and I'm painfully aware how long it takes to get a vaccine to market under usual circumstances. It usually takes years and even decades to get a vaccine approved by the FDA. 60 years of research for an RSV vaccine, and we still don't have one. RSV stands for respiratory syncytial virus. I used to work on that at the CDC. And respiratory syncytial virus is of huge public health concern in infants and young babies. It causes severe respiratory illness. 40 years of research for an HIV vaccine. Hepatitis C, herpes simplex, etc., etc. Each of these infections has its own challenges and complications in terms of making a vaccine. Why was it so easy for this one? So these are all good questions, and like I said, there are good answers. Let's start with the mRNA vaccines. What exactly is in these vaccines and how do they work? So there are 2 of them, like I mentioned, one by Pfizer and one by Moderna. But before I go there, I want to talk about something that everybody learns in high school. This is the central genetic dogma, and I think, who remembers that? Anybody remember that? Okay, good. I think this is a very simple concept, but I think it is fundamental to understanding how viruses work and how these vaccines work. So at the very top, we have DNA. Our genomes consist of DNA, and that DNA encodes ultimately protein. But before we get to protein, that DNA has to be transcribed into RNA. This happens in the nucleus. So in the nucleus, we have our DNA. It gets transcribed into RNA, and RNA is extremely unstable. It has to ultimately go out into the cytoplasm where it's made into protein. But it's really unstable, so to make it more stable, it becomes modified. And this modified version of RNA is called mRNA, messenger RNA. This messenger RNA then goes out into the cytoplasm where ribosomes will come in and they will translate it into protein. So the vaccines consist of such mRNA. Oh, one more point, sorry. So our genome, oh, it's not going backwards. Our genome is DNA. SARS-CoV-2 has an RNA genome that is encapsulated in this membrane into which are embedded these proteins called spike protein. I'm sure everybody has heard about spike protein in the news, right? So what happens is that the spike protein, when the virus finds a cell, the spike protein will bind to these receptors on our cell surfaces called ACE2 receptor. And upon this binding, the spike protein will undergo a conformational change and then will fuse, the virus will fuse with our cell membrane, and then that RNA will enter the cytoplasm of our cell where it becomes translated into protein, all of the proteins of the virus, right, all of them, so that new copies of the entire virus can be made. All right, so the vaccines consist of mRNA, and this encodes the SARS-CoV-2 spike protein. The spike protein is very immunogenic, meaning that it induces a good immune response in humans. Once this vaccine, and this vaccine can fuse with our cell membranes exactly the way it is. Once it is delivered into your cells, your cell proteins, your ribosomes, use this mRNA, this messenger RNA, as a message to make the spike protein from the insert, from that gene. And this usually induces an immune response in the form of antibodies and T cells. If your body is then later infected with a real virus, your immune system will recognize the spike protein on the surface of the virus and will quickly react to that. But RNA is very unstable, so it has to be protected somehow. It's usually formulated. Both the Pfizer and Moderna vaccines are encapsulated in this lipid nanoparticle, and they end up looking like these little vesicles right here, which protect the mRNA from degradation and also help improve uptake into cells. So this particle fuses with our cell membranes the way it is, and that RNA can then be delivered into the cytoplasm of our cells. Addition of cholesterol molecules into the nanoparticle makes the particle more fluid and also helps to improve its fusion with the cell membrane. Polyethylene glycol, denoted as PEG here, serves different functions. It hides the nanoparticle from your immune system, and the reason it does that is because we don't want your immune system to attack this whole thing. What we want to happen is for the mRNA to come out of here and be translated into spike protein, okay? And then we want the immune system to react to that, to the spike protein. So this whole thing has to be hidden from the immune system until that happens. So PEG helps with that. PEG also makes the particle more water soluble because there are many different hydrophobic parts here, and it slows down the degradation of the particle because the particle does degrade after a while. mRNA vaccines are new in the sense that there has never been one approved for use in humans before, but the technology and the concepts itself are not new. Reports of the first successful protein production from foreign RNA in animals were published in, can't see it from here, 1990. And that technology has been refined ever since. Progress in the field has been hampered mostly because both scientists and investors were concerned about the inherent instability of RNA and that this would prevent its use as a therapeutic or vaccine and its delivery into cells. Anybody who has ever worked with RNA in the lab knows how frustrating it can be to handle it. However, research in the past 30 years has shown that the stability of RNA can be improved through various modifications and delivery methods, including the nanoparticle that I just described. One of the reasons why SARS-CoV-2 vaccines could be made so quickly is because all this basic science was already in place at the start of the pandemic. And although SARS-CoV-2 vaccines are the first mRNA vaccines to be approved for use in humans, several mRNA vaccines have undergone clinical trials in humans before for at least 4 infectious diseases. Okay. This would be, rabies. Okay, so we had clinical trials for mRNA vaccines before. One of them was for rabies. Influenza. Sorry. Where should I point this? Oh, cytomegalovirus infection. So cytomegalovirus is a herpes virus that is one of the causes of mononucleosis, among other things it does. And finally, sorry about that. Oh, and the last one is Zika virus. Who remembers Zika virus? It caused a pandemic about 5 years ago. I was actually pregnant at the time, so I was super freaked out. But what it does is it's a mosquito-borne virus, and if pregnant people become infected, especially early during pregnancy, it can cause microcephaly in the fetus, small head circumference. So it's also of huge public health concern. So many people are worried that the foreign vaccine mRNA could somehow integrate into our genome, kind of like HIV does. But that is really not possible, or shall we say very unlikely. This is HIV right here. When HIV enters our cells, and HIV also has an RNA genome, just like coronaviruses do, when it enters our cells, it does not get translated into protein right away. Okay, so it does not get, It does not get translated into protein right away. It is converted to DNA instead. So coronaviruses have an RNA genome, they get made into protein. HIV gets reverse transcribed into DNA. And that DNA then goes to the place in our cell where DNA happens to reside, and that is the nucleus. Once in the nucleus, it gets integrated into our genome where it stays forever. The synthesis of DNA from the RNA, the HIV RNA, happens with help of an enzyme called reverse transcriptase. The synthesis, the integration of the resulting DNA into our genome happens with help of an enzyme called integrase. Both of these enzymes, reverse transcriptase and integrase, are encoded by HIV. That means that HIV has the genetic information to make these proteins. The sequence of events that occurs when SARS-CoV-2 mRNA enters our cells is completely different. Both the vaccine mRNA and the protein that are made from that mRNA they only stick around for a short time. The mRNA probably sticks around long enough until it gets made into protein, and the protein sticks around long enough until it induces an immune response. Then after a while, they degrade. Unlike with HIV, there is no reverse transcriptase to make a DNA copy of the RNA genome, and so the DNA wouldn't go to the nucleus. And even if that did happen, there is no integrase to integrate the DNA into our genome. However, people are still concerned about other things. So one other concern is that the foreign nucleic acid, the foreign mRNA, can still insert into our genome using line 1 elements. Line 1 stands for long interspersed nuclear element 1. And these are elements in our genomes that can move around. They can jump around from one place to the other, and that's why they're also often referred to as jumping genes. Line 1 elements encode a reverse transcriptase function. So the concern is that the mRNA vaccines would somehow hijack these reverse transcriptase and integrase functions of these elements inside our genome. However, there are plenty of data showing that line 1s preferentially move their own genome, and this is just one example of a published paper showing that. There is no reason to think that a foreign mRNA from a vaccine that comes in would have some sort of advantage over what is already in our genome and would be reverse transcribed and integrated into our genome by these elements that exist in our genome. So long story short, any concerns about the vaccine integrating into our DNA or becoming a permanent part of our genome are completely unfounded. Okay, so these are the mRNA vaccines, but there are also the virus vectored vaccines. There are currently 2 of them that are in use, well, sort of. One made by AstraZeneca and one by Johnson & Johnson. Let's talk about those now. So for vectored vaccines, you need a virus as a vehicle to get the vaccine DNA into our cells. Usually adenoviruses are used, and these are viruses that cause the common cold. The vaccine consists of a adenovirus vector with an inserted gene that codes for the SARS-CoV-2 spike protein, the same protein that was used for the mRNA vaccines. The notion of using a virus as a vector to deliver vaccine genomic material into our cells is based on the ability of viruses to attach to host cell receptors and insert their DNA into our cells that way, just like the process I described at the beginning. So we're basically taking advantage of that process. Upon injection into a vaccine recipient, the vaccine vector should enter the cells and serve as a code for host proteins to make the SARS-CoV-2 spike protein from that inserted gene. Ideally, the spike protein will then act as an antigen to prime the immune system to recognize SARS-CoV-2 at a later time if the human body is infected at a later time. So it's basically a variation on a theme. Adenoviruses are particularly suitable for delivering foreign genes into cells because they have a double-stranded DNA genome that can accommodate large segments of foreign DNA, and because they infect most cell types without integrating into the genome. So I want to stress here, this is DNA now, okay, so the vaccines have a DNA in there, not mRNA like the other vaccines. So on the genetic dogma, we're at the top here. So that DNA, once it enters our cells, it would have to be both transcribed and translated into protein. Okay, so however, there's a problem with these adenovirus vectored vaccines. Due to the prevalence of infections of humans with adenoviruses, because they do cause the common cold, as I already mentioned, most people already have antibodies against these. So and these antibodies could reduce the efficacy of these vaccines, meaning that when this enters your cells, if you have antibodies to this, it's going to attack the whole thing before your body has a chance to even make the spike protein. So that renders the vaccine useless. To get around this problem, AstraZeneca investigators used an adenovirus of chimpanzee origin, which normally does not infect humans, so the thought is that most humans would not have antibodies against this particular virus. Johnson & Johnson investigators used a human adenovirus. However, they used adenovirus 26, which is an adenovirus that most people don't have antibodies against that neutralize this vector. So, therefore, potential recipients of both the AstraZeneca and the Johnson & Johnson vaccines are less likely to have pre-existing antibodies against the vector itself. To further optimize the vaccine vectors, both AstraZeneca and Johnson & Johnson investigators further deleted 2 genes. One of them regulates viral replication, and this ensures that when you get this injected, it's not going to go into your cells and cause an adenovirus infection. and another large gene that is really not needed for any of this, and that creates more room inside the vector for the inserted gene, the spike gene. So basically, that's how these vaccines work. All of them were tested in clinical trials, each in tens of thousands of people, and all are very, very effective, much more effective than we originally thought. For comparison, the annual flu vaccine has an efficacy of 50 to 60%. But how exactly do these, and since the clinical trials, millions of people have been injected with these, myself included. So about the clinical trials, how exactly do they work and can we trust them? Okay, so clinical trials, particularly in the third phase, are randomized, double-blinded, and placebo-controlled. But what exactly does that mean? Randomizing means that participants are randomly assigned to either the treatment group receiving the actual vaccine or a control group receiving a placebo. Randomization eliminates unwanted effects that have nothing to do with the variables being studied. And the variables being studied are safety and efficacy. So you want to look at those two things in a vacuum. Double blinding means that neither the investigators nor the participants know what they're getting. They don't know if they're getting the placebo or the actual vaccine. Double blinding leads to more authentic conclusions because it reduces researcher bias. Placebo-controlled means that one group is receiving a placebo, a substance that has no therapeutic effect. And this ensures that the effects that are observed in the people receiving the actual vaccine are real and that they result from vaccination. So all the SARS-CoV-2 vaccines were tested in these clinical trials that I described without exception, including the AstraZeneca and Johnson & Johnson vaccines. There has been some controversy surrounding these vaccines because out of millions of people vaccinated, a small number of people developed blood clots at some point after vaccination. However, I want to stress that the number of blood clots that have been observed are still below the normal expected number of blood clots normally observed in a normal population. And the FDA is currently trying to figure out which subgroups are most affected by this and come up with some sort of regulation to help guide the use of these vaccines in these subgroups. But I also want to mention, and the vaccination of using these vaccines were suspended, which is good because we want to investigate what is happening. But I also do want to mention that suspension of vaccination may actually result in an increase of blood clots. Why? Because severe COVID-19 itself can cause blood clots. So when weighing the risk about whether or not to get these vaccines, these virus-vectored vaccines, I think it really helps to look at this graphic. I'm pushing the button. Okay, this graphic right here. So if you were to receive one of the virus-vectored vaccines, or I guess AstraZeneca vaccine, you probably have a 0.0004% chance of getting a blood clot. In comparison, use of the birth control pill leads to a 0.05 to 0.12% chance. And we have decades of data on that. So, and then smoking increases that to 0.18%. Having a severe case of COVID-19, 16.5% chance of blood clots. So lastly, in terms of vaccines, I wanted to talk about vaccination of pregnant women. There was uncertainty about this at the beginning. Is it safe? Is it beneficial? And the data are beginning to emerge on that. This is just one example of a published paper, but there are many more papers coming out on this topic, showing that not only is it safe for both mother and fetus and child, but it is also beneficial, potentially beneficial to the baby. The authors of this particular paper found vaccine-induced antibodies in the cord blood, which suggests that the antibodies made in the mother cross the placenta to the baby. And this has also been previously observed after vaccination of pregnant women with influenza virus vaccine, I highly recommend the flu shot during pregnancy. This is not medical advice, I'm just saying. And then also observed after vaccination with the Bordetella pertussis vaccine, which Bordetella pertussis is a bacterium that causes whooping cough, and then other vaccines as well. Whether these antibodies actually protect the baby from future infection with SARS-CoV-2 remains to be determined. But now for the important question. How did we end up with not just one, but several highly effective vaccines in less than 1 year? Because there are more vaccines than I described here today. So there are several reasons. The most important is probably because we already had a very solid foundation of basic research in place. Okay, all right. Decades of research on mRNA vaccines, and then also conventional vaccine methods involve attenuated or inactivated viruses. That's what we all know, right? Before these mRNA vaccines came on, everybody thought that a virus is either inactivated or a weaker version of the virus. But these methods are very time-consuming. Basically, you have to grow the virus in cell culture repeatedly and harvest it and grow it again, and again. And this takes a long time. mRNA vaccines can be made a lot more quickly because you don't have to do all that. An additional reason, after years of research with other coronaviruses, because we know of 6 others that infect humans, scientists knew that the spike protein was the important immunogenic protein that we needed to focus on. And in my opinion, we also had quite a bit of luck, because it could have turned out that the spike protein was not the important immunogenic protein that we needed to focus on. Or it could have been that the spike protein has slightly different properties in this particular virus that are not beneficial for vaccination. One last point. You know the maxim, good, fast, or cheap? You can pick 2, but you can't have all 3? Okay. Well, under no circumstances was this endeavor cheap. In short, vaccines are one of the biggest success stories of modern medicine. The World Health Organization estimates that vaccines save 2 to 3 million lives every year, and that they prevent countless other cases of hospitalization and severe disease. So if you haven't yet, please get your vaccine as soon as you can. Thank you. I had one last slide. No, I'm done talking. I'm done talking. Yes. Sure. Yeah.
Guys, a great opportunity to ask Dr. Rey some questions.
Directly, thank you. As far as regulations of wet markets across, how do you feel that would affect our needs for, I know we're always going to need a vaccine, but these things jumping and crossing.
Oh, you're asking if we need to be revaccinated, boosters, or, I'm sorry, the wet map?
The wet market across the world, like where we think, I know there's many speculations of where these come
emerged.
from. Yes,
right, so the wet markets were the first suspicious place. It still has not been shown that that was where it originated. It seems like the logical place where it would happen, but recently the World Health Organization sent out a group of people to China to investigate, and it seems that there are these farms where the animals are taken to the wet market. So before the wet market, the farms where these animals are actually farmed. And it seems like that could be a more likely source, because every single investigation into the wet market shows that that was not ground zero.
The RNA platform that Pfizer and Moderna uses has been around for a while, from my understanding, and there is speculation that that same platform can be used in the cure of cancer and
Yes.
other diseases. Is that correct?
Yes, absolutely correct. So what's great about the mRNA vaccines is that unlike attenuated or inactivated virus vaccines, you don't have to grow the virus in culture like I mentioned. And with that, basically all you have to do is you stick in the gene that of interest. Okay, so for cancer, for example, cancer cells have protein markers on their cells, proteins that they preferentially express, and those could be, the genes for those could be inserted into the nanoparticle, and then that could be that would then be injected, and then the body would make that protein, and then the immune system would react to that protein. It would make antibodies. So if cancer cells appear at some point in the future, then they would be attacked by the immune system. Although, to tell you the truth, I'm very pessimistic, I'm sorry. As far as cancer vaccines go, I'm a little more pessimistic about those. But as far as other viruses go, I think that this is very promising. And I don't know about HIV. HIV is a problem in itself. But I'm particularly excited about potential RSV vaccines, like using the mRNAs for RSV, because that's a huge problem. And it's a field that's been just wrought with issues for a long time. So
do you know if you'll have to get extra booster shots, kind of like the flu shot, and if so, how often?
Okay, so I have thoughts on that. In my opinion, and this is just my opinion, unless you're elderly or have some sort of immune deficiency, I don't think we're going to need booster shots. And the reason why is because you get this vaccine, right? You have it now, and even if the antibodies only last 6 months or a year or whatever, we still have the memory B cells, we still have the T cells. But in addition to that, the virus is not going anywhere. Okay, when I was looking at the Johns Hopkins map a year ago, and it had just emerged it had just come into the United States, and I saw all the red dots, and I was like, this is not going anywhere. Staying at home for 2 weeks is not going to do anything. But it's going to continue to circulate, and even if we have herd immunity, which means that 70% of the population is vaccinated, protecting the rest of the 30%, the virus is still going to circulate, and it's going to infect you, even if you're vaccinated, probably, right? Now, you're not going to get sick from it. The vaccine is going to protect you from disease, but it might still replicate in your cells to a certain extent. That infection is a booster in itself, okay? So the virus comes in, your immune system reacts to it, you don't have that many antibodies, but all of a sudden, oh, I've seen this before, and it starts making lots of antibodies. So that is a booster. Natural infection is a booster. So, just like with the other coronaviruses, I think that's what happened with the other coronaviruses, the 6 that I mentioned. They all emerged from animals. They're all zoonotic a long time ago, and then they co-evolved with us, and they became weaker, and now we get them. Every time you get a cold, it's probably a coronavirus or an adenovirus.
So is there anything that a normal, healthy person should worry about before getting the vaccine?
No.
No? Okay.
No.
Is there any correlation between the food we eat, like over-processed food, and our ability to fight viruses, or how the vaccines react with our body?
I don't think so. I mean, eating healthy is definitely a good idea. When your immune system will suffer if you eat too much fatty food, or